All right, last problem for today. We're going to do this one. I think with friction, it might be a little bit harder. We've got two boxes that weigh 50 pounds each. They're on those inclined surfaces. If it's a smooth surface like ice, then it would have to be perfectly balanced, 50 pounds, and they both have to be 45 degrees or both have to be 30 degrees. You should sort of check and make sure motion occurs, because the answer could be 0 if no motion occurs. But I'm convinced that motion occurs in this case here. I might have to do a math check to do this one. Maybe I'll do this one Friday night or during our next class, but that's going to take a little bit more. I feel like, so I know how to do this one with F equals MA, and I would get started. And I just thought of something that 1/2 mv squared. What is that? Kinetic energy associated with a moving object. It's a scalar, right? It doesn't scalar. It does not have direction. That's one of the big differences between work and energy, scalar, and impulse momentum. This is not asking about time. It's not an impulse momentum problem, but those have direction and they're vectors. But we're going to square that velocity, which is a vector quantity. The square of it can't be a vector any longer. It's a scalar quantity. So each box weighs 50. Somehow the angles have to come into play. Start with a free body diagram. There's that box. It would have a normal force. No frictional force. That would be 1527. It will have a tension. And it'll have a weight. And that weight will have a component. That's going to be 50 root 2 over 2. And that is going to be 50 root 2 over 2. I won't need that unless I need a normal force. I don't need a normal force unless I need a frictional force. So I might be able to do this as a system. Then I'm going to have some forces here that I don't really need to figure out. For this guy here, I have an equation. It's released from rest, so V1 equals 0 for both. For both. So we can say that the work done equals the final velocity. The work done, so we're gonna forget 1/2 mv1 squared plus integral FDS equals 1/2 mv2 squared And this is just for the blue box, because that's the only one we're looking at right now. At some point, we may need to relate these velocities to each other. Relative dependent motion. So that's S of the blue box. That's S of the green box. The length of the chord is equal to SB plus SG plus some others, fixed lengths. And so the change in the length of the chord, delta LC, equals 0, equals delta SB plus delta SA. This tells me that delta SA equals minus delta SB. I got the wrong color. Blue and green. Blue and green, blue and green, blue and green. This tells me that SG is negative SB with this. So if this goes 1 foot plus 1 foot, this one here goes minus 1 foot, then that makes sense. And so let's say that we think the one on the steeper incline goes down, makes sense, and that's 1 foot. That direction is in the 50 direction, 50 root 2 over 2 pounds times 1 foot minus T times 1 foot. Those are the forces times the distance equals 1/2 m. They have the same masses, so I won't put the subscripts on them. M V blue squared. So I have two unknowns, T and VB. I have the relationship between VG equals minus VB, AG equals minus AB. Dependent equation, take the derivative, you get velocity, take it again, you get acceleration. We can also do delta S over delta T, or just delta S, to get a relationship between the positions, velocities, and accelerations. I'm trying to get VB. I'm going to do the same thing on the other side, and it's going to be similar. I'll try and, I don't have any green or blue handy, but the tension is like that. And the weight is like this. This angle is 30. And so this angle is 30. And I want to know how much of it is like that. So 30, 30 right here. This line is perpendicular to this line, and this line is perpendicular to that line. So the angle between these two is 30, the angle between those two is 30. If you don't see it, it really comes into play when you have like a 40-degree angle or a 42-degree angle or a 51-degree angle. It's not as obvious, but the 30 is there. This one is W sine 30, right? 0.5 times 50 equals 25 pounds. Sine 30 is 0.5. Now S is in that direction. And my equation will be T times 1 foot minus 25 pounds. Like this was around 35 pounds probably, minus 25 pounds times 1 foot. I'm plugging it, just using this same equation here. With the positive direction that way. I think I want to go the positive direction the other way. Because I've defined my positive directions up here. If I end up using this equation, it has to be consistent with these positive directions. And so, keeping that in mind, I would probably write, the 25 is down. It would be probably 25 pounds down and to the right, but then it would be a -1, and then it would be minus T, but that would be a -1 foot. And I'd end up with the same equation at top equals 1/2 mvg squared. I have two equations with just two unknowns. No, I have two equations with three unknowns right now, but it's just two unknowns when I have that substitution. And because it's squared, I think it's just the magnitudes of them are equal is all that matters in this problem. So I want velocity, so I'm going to solve for t. This one here is this is minus t times 1 foot equals t. This is going to be, I'm going to figure that out, 45 for sine. However you want to figure that out, √2/2 times 50. 35.36. This is 35.36 pound feet. That's going to be minus 1/2 mvb squared is equal to t. And this one over here, forget this, we were doing some thinking, never hurts. T is equal to 1/2 mvg squared plus 25 pound feet. So T is equal to both of those. These two are equal to each other. So I'm just going to put an equal sign like that. Double check the screen. I can see you. You can see me. Let's bring that 25 to the other side. Minus 25 is going to give me 10.36. I'm saying this is equal to this. And I brought that over to the other side. Took care of those. Equals 1/2 mvg squared plus 1/2 mvb squared. Makes sense. And we know that those have the same magnitude. So let's just call it v. And it's a scalar like we talked about earlier, so we don't really have to worry about the direction. If we did this with F equals MA, we'd have to be very cautious about the direction in order to get the tension and everything correct. So 1/2, the masses are the same. One half mv squared plus 1/2 mv squared is 1 mv squared. And the 10.36 is foot-pounds or pound-feet. Figured I wrote that. And so v squared equals 10.36 pound-feet divided by 50 pounds over 32.2 feet per second squared. We know that that gives us feet squared per second squared now. V equals, and I have that number. I'm going to subtract 25. I have that number. I'm going to divide by open parentheses 50 divided by 32.2. This book is full of English problems. So it gives me 1.5. I hit the equal sign. That's going to give me like 6.66. And the square root gives me 2.58 feet per second. And that is the correct answer to 1526. Again, if I do another one tomorrow or Monday, very hard to squeeze these in on during the week. No, we'll do this F equals MA. F equals MA next class. And then impulse and momentum, which you guys are working on now with some homework. Good. Here to go. It's 4:45 on Saturday, and I wanted to be out of here by 2. No fault of yours, and it wasn't just making these videos. I had a little fire alarm here, and I went to lunch with my son. So I'm going to say good night and have a great rest of your week.